Hello, ToobTimers. So we've got a little mini project going on here right now. A very good friend of mine was complaining, I will say, commenting on the mushiness of his speaker sounds. He said the high end was somewhat mushy, and he thought it might be the crossovers. Well, that's a good place to start. So he took the crossovers out, and you can see it's from an Angstrom reference uh, speaker set, somewhere in the early 80s or mid 70s, somewhere around there. So I thought, okay, perhaps the electrolytics inside the crossover were a bit of a mess after being all that time dried out. I said, I'll take a look at it. So he over at his place the other day, and he handed this thing over to me, and I said, "All right, well, I'll take a look at it." He made the comment, the observation that this crossover had been worked on before, and it was rather interesting because the for some reason they put a 2 ohm resistor in series with the tweeter. Now, they may have done that for a couple of reasons. This particular brand of tweeter, it was a Philips tweeter, does react very well to high frequencies, and perhaps they were feeling that he's just trying to attenuate the high frequency sound with that. The only oddity is he did it with on one speaker, or the person did it on only one of the crossovers and not the other. Also, where these big 10-watt resistors are here, there's a pair of them in parallel to come to 6 ohms, and for some reason he replaced them. And those are in the tweeter circuit. Basically, this half of the crossover is the woofer circuit, and this half of the speaker is the tweeter circuits. So apparently, something happened to this 10 ohm resistor that he felt he needed to replace it, or she, and they replaced it. They didn't have the 6 ohm that was in there originally. They replaced it with a 12 ohm in parallel. I would like to comment on a couple of things. These banana jacks, my goodness, that could be the ballast in a ship. They've put so much solder on there. If you notice, there's black dots. I don't know if you can see it or not very well, but there are black dots. Let me lower this a bit. Maybe you'll get a better picture of the thing. There's black dots on the, that's how I should have started in the first place, on this coil form. It's overspray from some other project probably. Maybe the same project. But to me, these are indications of, if not poor workmanship, sloppy workmanship. And so when you're working on things, make sure it looks good too. That's kind of important. On the other crossover, I've already stripped it down to the coil. Stripped it down to the coils. And I tested all the components. I measured all the components. The woofer coil is 2.2 millihenries. The tweeter coil is 0.336 millihenries. The components that were glued down here, and they were glued down for a good reason. You can see it's glued here as well. It's glued to keep vibrations down. Those components, all the other components tested well. They all tested within spec, and the leakage on the capacitors, the electrolytics, were acceptable. They had acceptable leakages. So the question is, will the crossover change help? At this point, I don't know, except that I'll be replacing all these components with modern high performance parts that will likely have some kind of an improvement. These old electrolytics, maybe they're at different frequencies. It tested at one frequency, a kilohertz, and it was fine at a kilohertz. But it could also be bad at a higher frequency. There could be problems with the capacitor at higher or lower frequencies. Okay, maybe. I also could only test it on the original frequency scan. Raise it up and see this a little better. I also tested it at only a very low level. I couldn't put a good load on my speakers because I couldn't drive it. But if you look at it, these the bass response is right here, and these are the left and right channels overlaying on one another. Boy, they overlay quite nicely. Then here's the crossover point where it's beginning to attenuate. It no longer is responding to high frequencies because of the low-pass filter. It begins to deviate up here, but I would say this deviation is minuscule and means nothing for two reasons. One, you're only talking half a dB, and two, at this end, you're attenuating your high frequency anyway, so you're way down from your upper end performance where you should be. On the high end, the yellow one is the high pass of the left, which had the additional resistor in there. Oh, excuse me, it was the right. It was the left that did not have the additional resistor in there. And the red one is the right channel that did have the additional resistor in there. There is some spread, but nothing that I would concern with. What was interesting to me is how this right channel kind of poked up and down, and there's a little bit of a dip before it takes off, and to hit the crossover. Literally, is the crossover is where the low pass filter and the high pass filter intersect, and then the high pass filter takes over with the tweeter. Now, the resonant frequency of this speaker, this high frequency speaker, the tweeter, is 1,000 hertz, which means at 1,000 hertz, your thing's in resonance, and you really want to kind of stay away from there because you can very easily overstress. The tweeter could react unpredictably and likely with damage. This one, I measured it, a crossover frequency of 1.8 kilohertz, roughly. And when I ran it through my LT Spice program, I came with a 1.6 kilohertz crossover. If I said megahertz before on the other thing, I apologize. All in all, the crossovers look good. So I'm a little concerned, but this was only at 1 kilohertz. Although this runs the whole frequency, the components are measured a single frequency of a kilohertz, and the frequency scan shows it to be a decent crossover. But like I said, it was only done in milliwatts of output, not watts. So things are going to happen when you get higher frequencies and higher currents to go through it. We'll save that for a little later. So we've talked a little bit about our crossovers. You can see this one's been stripped down. I've got to order some modern capacitors and resistors to replace these. I don't want to hear people saying that just because it tested good, it means it's a good component. That isn't always true. Some components, like resistors, may break down under high currents. These film capacitors are good actors. They could probably stay there, but I'm going to replace them because with the modern dielectric parts. The electrolytics I worry about because once you start kind of shoving high currents through those things, they could become leakier and get a little squirrely with your output. So we will change those electrolytics out for a film capacitor. I have in this case I've got I don't know 10 microfarads of capacitance here or so. I'm going to make that 10 microfarad capacitance out of a film capacitor so that doesn't have that dielectric to mess you up 5 years from now. We're going to clean up this excessive soldering. We're going to pull these parts out, the banana plugs, and replace them with a little different kind of banana plug. And we'll call it a day. And if the problem still exists, it's probably with the tweeter. So, tube timers, I guess that's about enough for today. The next time I'll talk about this is as soon as the parts come in from being ordered. I'll order them from someplace to get them as quickly as I can. And we'll hope for the better. Tube Timers, I hope you enjoy. I haven't stressed this enough, but if you enjoy it, please subscribe to my channel. And then you'll be apprised of all the updates that are coming on. I'm trying to place an update once a week or so. So there should be something different all the time. I am still working on the 6P1. I'm building a circuit schematic of it as now, and it's a bit of a wire's rat's nest in there, but they always are. So we'll get that done pretty soon in another week or two, and we'll get back to that. But for right now, we're talking about Angstrom Company's reference speaker of the 1970s and 80s. So, Tube Timers, take care. I hope this finds you well, and have a good day.